Chapter 2, we're going to talk about matter. Section 1 is over how do we classify matter. What is matter? Well, it's anything that has mass and takes up space. This includes the air around us and the gases. Chemistry, which is what we're going to spend the semester doing, is the study of matter. So essentially we're studying atoms. Matter can be classified as a pure substance or as a mixture. Pure substances include any kind of matter that has a fixed composition or makeup, and they have to have a definite property. So for example, elements, which is anything that can be found on the periodic table, or compounds, like water. Water is always found as H2O, as a definite composition. Elements are made up of atoms. An atom is the smallest unit of matter. An element is a substance that can't be broken down into simpler substances by any chemical means. We know that it's an element because we can find it on the periodic table. An element is made entirely of the same type of atom. So if we have a chunk of copper, every single atom in that chunk of copper is going to be a copper atom. Elements are represented by a 1 to 2 letter symbol. They look like this on the periodic table. The first letter is always capitalized. If there's a second letter, it's always lowercase. There's not always going to be a second letter. For example, capital C stands for carbon. Capital H, lowercase e, stands for helium. The capitalization is very important when writing the symbol for an element. Little mistakes can mean a big difference. For example, capital C, capital O stands for carbon monoxide, carbon and oxygen. Whereas big C, little o stands for cobalt. It's a very big difference. Carbon monoxide is a toxic, noxious gas that can actually kill you, whereas cobalt is a metal. Some of the elements that we find inside the human body are very similar to the ones that we find and make up the crust of the earth, like silicon and oxygen. Roughly 30% of the earth is made up of oxygen, but it's not just in the air that we breathe. Just like 65% of your body is made up of oxygen. Most of it is not in the form of the gaseous air that we breathe. Most of that oxygen is going to be bound up with other things like hydrogen to form water, or calcium phosphate. The phosphorus and the oxygen make the phosphate, and that makes up your bones and your teeth. So a compound is two different elements that are chemically bonded. It's still considered a pure substance because it always comes in a fixed ratio. For example, H2O, hydrogen and oxygen, make up water. A molecule is the smallest unit of that compound. So two oxygens together or two hydrogens together, those would form molecules. Compounds can be broken down into other things. For example, water. We'll actually do the demonstration in class where we break water apart. We'll form hydrogen gas and oxygen gas, and you can actually see that being formed. Now, a compound and a molecule can both be represented by what we call a chemical formula. That's what this big, colorful series of letters and numbers represents, as a chemical formula of something. Symbols of the elements are provided. For example, carbon is a C, hydrogen is just a capital H, nitrogen is an N, oxygen is an O. So the symbols tell us what element is present in this formula, and the subscript, these little numbers down below, tells us how many of that type of atoms. So for example, here we have a carbon atom, but there's 16 next to it. That tells us there are 16 carbon atoms in this compound. There's 10 hydrogens, 2 nitrogens, and 2 oxygens. So a subscript, just like a submarine goes down below, the subscript is the number down below. It tells us how many of that type of atoms there are. Later on, we'll learn about superscripts, which are the little numbers up above, just like Superman flies through the air. But for right now, all we need to be concerned with is what a subscript does, and that just tells us how many of that type of atom there are. If there's nothing there, we would assume that it's a 1. If there's a number out in front, it's just like in math class. Let's say there was a 2 here. That's called a coefficient, and that becomes a multiplier. And you would take everything, you would distribute that out times whatever that coefficient number is. So let's say there's a 2 here. 2 times 16, 2 times 10, 2 times 2, 2 times 2. So that coefficient just tells you how many of this compound you have. If there's no subscript, we just imply the 1. A mixture is a compound or elements that are mixed together but not bonded. So much like our fruit salad here, those things are not bonded together. We can actually separate them. Substances that make up a mixture keep most of their own properties, so our fruit isn't going to taste like the surrounding fruit. And we can separate it by physical means. We can physically remove them with our hands. Iron and aluminum could be separated with a magnet because iron is magnetic and aluminum is not. Coffee grounds and water can be separated with a filter. So those are examples of mixtures. A heterogeneous mixture is one that is different throughout or chunky. The separation can be seen. I like to give the example of our trail mix here, or like Italian salad dressing. A homogeneous mixture is one that is the same throughout and there's no separation that can be seen. Like the milk that you drink at lunch. It has been homogenized, so all of that fat that has been pulled out of the milk and put back in, you can't actually see the chunks of fat in the milk, but you can taste the difference. Metal alloys are another example of a homogeneous mixture. The air around you, milk and salt water, are all homogeneous mixtures. The other example we came up with in class was like ranch dressing. So if this one is Italian dressing, this is ranch. The term miscible sounds a lot like mixable, which is handy because miscible just means that the substance can be mixed together. For example, milk and coffee. When you pour them together, they mix up, and they're very difficult to separate. Something that is immiscible would be like this oil and water here. Those substances cannot be mixed. We can use something to emulsify this to cause those little fat globules to break up into little teeny tiny droplets that won't settle very easily. But an immiscible mixture cannot be mixed together. So this would be, again, like your Italian salad dressing.